Hi, this is Alex. Welcome to a video of how to configure GV STRATUS systems within the GVConfig tool. It's really important to use GVConfig because it allows you to apply all the customer requirement parameters needed to produce a valid K2 and GV STRATUS system in one easy-to-use application. In the customer info section, you should apply the details about the opportunity and project so that it's clear what the configuration applies to. In the System Notes section, I find it really useful to document a summary of the customer requirements so anyone looking at this config in the future can understand what we're trying to solve and deliver. In System Settings, I need to apply details of the media formats that the system will cope with. This is important because these parameters are used elsewhere in the configuration tool to calculate storage capacities and bandwidths needed by the storage, networking, and other components. I can apply separate format settings for HD and for SD, which allows me to configure systems with either SD, HD, or both types of formats. The number of mono audio tracks can also be applied here, as can the audio bit depth and ancillary data if they're required within my system. Now it's time to start telling the configurator about storage and networking requirements. First, let's talk a little about how the configurator uses bandwidth data. By default, bandwidths are defined in megabytes per second. It's really important to get this correct, as a mistake will have a dramatic effect on your bill of materials. If you require to work in megabits per second, you can change this via the application settings on the menu bar. If you just want to apply this change to the current configuration, you can do this via the configuration settings. I can now start defining the storage, network and server ports for my system. GVConfig allows you to create systems with SAN connected and distributed, also known as standalone, K2 devices. We'll cover both here. Let's start applying storage settings for the high-res material the system will store in a K2 SAN. I can assign values for the quantity of HD and SD hours required by the customer. Alternatively, if your customer requests a quantity of storage in usable terabytes, I can apply that instead here. The configurator uses these values and the system format settings defined earlier to calculate the correct storage configuration and add the relevant components to the bill of materials. In the storage configuration section, I can tell the system whether to use online or production storage type chassis and drives. This decision really depends on a number of factors, but in general production storage is cheaper and offers more capacity per disk. Online storage is more performant, providing more bandwidth per disk in production-intensive situations, for example where I have a lot of off-speed playback requirements or a very bandwidth-intensive system that needs to be physically small, say in a mobile system like an OB truck. Note, for online storage I can select between RAID 5 and RAID 6 configurations. Whether selecting online or production, the system can be set to auto-choose the correct drive capacity, or I can force a drive capacity through the drive size selection. If my customer requires the SAN to be configured in a redundant configuration, I can select that using this checkbox. I can also select live production mode for either type of storage if I have a requirement to support the playback of very short duration content back to back. In the Quick Info section, you'll immediately see the impact of your storage choices, including the number of storage chassis, the configured capacity, and bandwidth. You'll also see the pricing of your system on the right-hand side. Watching the Quick Info section allows you to refine your settings to best meet your customer requirements. Now let's apply the network requirements for my system. You can apply an overall figure for CIFS and FTP bandwidth for both record and play streams within the system. There is a handy bandwidth calculator which allows you to add bandwidth and streams to record or playback from the SAN. However, I find it helps, especially in more complex systems, to define my network requirements in the Details table. I access this by selecting the Show FTP and CIFS bandwidth details checkbox. This allows the configurator to capture and correctly calculate the bandwidth based on the system formats defined earlier, and importantly the correct number of traffic streams, which affects the number of FTP servers in the configuration, for each type of connection to my system. I can edit each usage name to reflect the types of connections my customer requires. The bandwidth calculator allows you to assign bandwidth and streams per usage type. The details table helps make it really clear what your customer wants and improves documentation of the configuration, especially if you need to change it later during the project. If my customer has asked for redundancy, I can apply redundant FTP service to my configuration, which ensures FTP resources are duplicated within the bill of materials for resilience. This setting also affects the quantity of network ports, including 10 gigabit Ethernet uplinks applied to the network hardware section of my bill of materials. If I need extra connections to support third-party devices connected to my system, I can add those using these fields. Now it's time to configure the number of server ports required for recording and playback. I can use K2 Summit Production or transmission clients on my SAN. However, to be cost effective, we recommend you only use K2 Production clients where you require a codec format over 100 megabits per second or where you need a specific production feature, such as a SAN-connected dyno or channel flex options, which are only available on a K2 Production grade client. I'm going to use transmission client ports for my ingest and playback, as in my example, I only need to support XD-CAM HD at 50 megabits. Add the number of record and playback ports that you require. You can also specify QC and preview ports or mix effects ports if necessary. If you need a mixture of SD and HD ports, apply the number you require to both the SD and the HD channel sections separately. In advanced settings, I can define whether these Summit servers need to connect to the media storage via fiber channel if necessary. By default, the system will configure for iSCSI connections. However, in some cases, fiber channel connections can be cheaper. Any change is reflected immediately in the Quick Info section within the configurator. By default, transmission servers offer only half their ports as available record channels. To make all ports record capable, check the bidirectional channel option here. This option allows transmission clients to cost-effectively replace production servers in ingest applications for many system formats without adding any extra Summit hardware. If I need to apply a Dyno S to my system, I can apply those within this section. There are a number of standard Dyno S configurations designed to cater for common customer use cases. I can assign the number of Dyno S systems needed. Please remember that you need to add bandwidth in the Network I/O section to cater for media movements to and from standalone Dyno systems. This section is where I add distributed, also known as standalone, clients. Add a configuration by clicking the plus key, then define the type and quantity of devices using the drop-down. If I select a production grade Summit, I can define my hard disk capacity and whether there are external direct attached storage chassis. This is a really effective way to provide a small number of baseband ports to a system, but with a higher storage capacity than a single Summit with internal storage only. If I select a transmission grade Summit, the storage parameters are fixed. However, these do offer more cost-effective options. If I require one or more K2 solos in my system, they can also be added as a distributed K2 device. I need to ensure I add enough bandwidth to my SAN system to accommodate these distributed devices, up to the limit of 40 megabytes per second for a standalone Summit. If I require bidirectional channel support or other codec options, I apply those here. If my distributed clients are providing ingest or playout in an AVC Intra, DVC Pro or DNX HD system, I must ensure they are licensed for the format by checking the relevant options here. The bill of materials will update to reflect your selections. If I require GV STRATUS proxy generation on my distributed clients, I need to select App Center Pro here. This checkbox allows the configurator to include Ethernet ports on my network switches within the bill of materials. If your customer is providing the network infrastructure to support your distributed clients, you won't need to check this box. Finally, for the K2 Summit section, the Application Software tab allows me to add various options to my system to support media synchronization between K2 systems, time delay, additional App Center seats, and to select the type of GV Guardian monitoring system required. Let's quickly review the Bill of Materials. By selecting the Bill of Materials tab, I can review what the configurator has built so far. As you can see, the Bill of Materials is divided into logical sections to allow me to check that the components expected are actually included. Now it's time to add the Stratus components to my system. I select the GV STRATUS section, and GVConfig presents the options for Stratus clients, core services, and site licenses. In the Clients subsection, I can apply the number of Stratus clients required by the customer. These are added by license type and depending upon whether they are low-resolution proxy clients or high-res clients which will provide access to the native media stored on the K2 system. Users are expected to know which client licenses are required for each feature, but to help you, a handy lookup table is available within GVConfig under this blue info button. Remember that a Stratus Flex license includes access to the EDIUS editor using Proxy media. GVConfig automatically selects the core server type according to the number of clients that I add. In the Proxy section, I define what proxy quality is required within the system. In Stratus version 4.5 and above, there are 3 available options for an H.264 proxy. Low is 1 megabit per second, medium 3 megabits per second, and high 5 megabits per second 720p. Note, the blue icon provides a useful tooltip to remind you of these qualities and bit rates. By default, the system will automatically calculate the proxy storage available based on the selected proxy quality and according to the base proxy storage capabilities of the core server that is applicable to the config. The number of configured proxy hours is visible within the Quick Info section. If you need to define a specific quantity of proxy storage in hours, you can apply it here. Note, GVConfig may select a larger core server type if the proxy quantity exceeds the threshold supported by the originally selected core server. If dedicated proxy storage is required on physically separate hardware, then GVConfig will assign a Stratus B1 or larger core server, as only these support proxy storage that is physically separate from the core server itself or the SAN. In the Proxy Scavenge section, I define how many concurrent streams of proxy generation are required for file-based material created within the system. This would include content imported as files, ingested from ENG formats, rendered or conformed after editing, and some archive restore processes. You need to assign values for SD and HD scavenge streams as necessary. GVConfig uses this data to add the correct number of scavenge servers to your bill of materials. If you require support for proxy generation on K2 Summit production servers in channel flex mode or want to remove the need for proxy generation on distributed clients, select or deselect those options here. In the conform section, I can define what ratio of conform and render servers are added to my system based on the number of clients. If customers request N+1 servers for resilience, these can be added here through the checkboxes. Conform applies where assets in Stratus need to be flattened into new media clips. Render applies to the EDIUS editing process as a final step to create new media assets in the system. You can modify the ratio of servers to clients to achieve the number of servers in the bill of materials to suit your customer's requirements. As a guide, conform and render server ratio somewhere between 6:1 and 10:1 makes sense in most systems, depending upon customer workflows. The VTR ingest section allows me to define whether my system includes the Stratus VTR ingest application and how many client seats are necessary. In small systems, with fewer than 20 clients, I may want to avoid using a K2 SAN and instead rely upon distributed clients to keep my configuration cost effective. In this case, I should force my core services type to Express in the core services options. This now allows me to set the Stratus storage type to K2 distributed clients, which prevents GVConfig from applying a K2 SAN to the bill of materials. In core services options, I can also define whether my system has a fault tolerant configuration, which selects a hardware resilient type of core server hardware. Express systems cannot support fault-tolerant servers.
If I don't require fault tolerance but do require a backup core server, I can select the cold standby backup server option here. Please note a cold standby server only supports a small number of high-res only clients and a specific documented standby workflow which may not suit all customers.
I can apply site licenses to my Stratus configuration in this section. There are individual selections for archive, multi-site, the rules engine, transcode integration, EDIUS field editing and support for Aspera. Note, in order to apply a transcode license, I must first include the rules engine. In GV Stratus 4.5 and beyond, we will offer support for VM-based core services. Selecting whether the core services or render and scavenge servers are virtualized will determine whether GVConfig applies GV-provided server hardware and software to the bill of materials, or only the software licenses required for a virtualized solution running on customer-provided server hardware.
The last thing I need to do is define the high-resolution editors connected to my GV Stratus system. GV Stratus systems can include a mixture of GV EDIUS and any of the third-party editor types. For each editor type, I define the number of editor seats, whether they will be working in HD or SD resolution, how many edit streams are supported for each editor, and how the editor is connected to the system. High-res connected editors assigned here automatically impact the K2 SAN bandwidth, storage and networking calculations used to define the bill of materials. iSCSI connected clients also impact the iSCSI licensing of the K2 media servers. Standalone Avid editors can be connected directly to the K2 Stratus system via iSCSI, but note, Fibre Channel is not supported. However, for the best GV Stratus integration, we recommend the Muse engine. This supports Avid standalones and interplay connected systems, offering media and metadata interchange. Please assign the number of Muse streams which need to be supported between the Stratus and Avid systems. Muse connections are supported in 3-stream blocks on customer-provided gateway server hardware. The Muse engine also requires the Stratus rules engine. High-resolution EDIUS and Adobe clients each include a Stratus Express client seat per editor. This is included in the calculation of core server type, but are not applied as additional client seats in the bill of materials, as they are included in the price of the editor integration. Stratus Express client seats are not included for Avid editor seats. You must add a Stratus client seat for every Avid editor seat which needs to access the Stratus system. Finally, let's select the bill of materials and quickly review what the configurator has created for us. GVConfig has added the components needed to deliver my GV Stratus system. If I find anything is missing, I can go back to the relevant section and make changes at any time. I hope this video has been useful. If you have any questions, please contact the GV Stratus specialist in your region. Many thanks for your time.